All right, we're going to do 1.6 part 2. So you should have 1.6 part 1 out. We can add these to it. And on part 1 we did the first 3 examples, so this will be example 4. And example 4 is going to tell us to graph y equals the cotangent of x. On Friday, or in part 1, we did all the tangent graphs. We did 3 tangent curves. So we're going to look at a tangent graph. If you have your chart somewhere handy, you should probably have that sitting up on your desk, because that might help you as we go through these. We're kind of just graphing down the cotangent column on this first graph. So you can kind of follow along and see how the cotangent graph works. All right, what we want to do is we want to first look at the chart and see where the cotangent is undefined. Because when we did tangent, just as a quick reminder, the tangent of x, if I put y equals the tangent of x, I had to find out what would make x equal pi over 2 and what would make x equal negative pi over 2. If you go back to the very first example on your notes from Friday, you'll see that we put a dotted line at pi over 2 and a dotted line at negative pi over 2, because that's where it was undefined. That's where it was no value. It says undefined on our chart. And so we can't graph anything on that point. So we put a dotted line as kind of a placeholder. It tells us that you can't graph anything on. Now the graph itself can jump over that line and start over again as you go around the circle, but there would be no values for those 2 points. That was on the tangent curve. Now as we move to the cotangent curve, the cotangent curve is not pi over 2. Because look at the cotangent. Where is it undefined? Right at the top at 0, isn't it? And as you go down that column, it's also undefined at pi. It's also undefined at 2 pi at the bottom, which is also a 0 if you look at your unit circle. So what we're going to do is we're going to take whatever's after the cotangent, and we're going to set it equal to 0, and we're going to set it equal to pi. That would be where the dotted lines would be on the cotangent graph. Cotangent graph, you've got an undefined at 0, you've got an undefined at pi. So we're going to set it equal. Now, it's already solved for x, so you don't have to worry about solving this one because there was nothing next to the x. So we're going to go straight to our graph. We're going to draw your x and y axis and go over to pi and make a dotted line at pi. But the question becomes, how do I make a dotted line at 0? 0 looks like it's the y-axis. How do I make the y-axis become a dotted line? Well, what I do is I just make a thicker dotted line over it so you can kind of see that it would be a dotted line. Okay, that would be your vertical asymptote. If you remember from Friday, we called it a vertical asymptote. A-S-Y-M-P-T-O-T-E. It's a line that shows you that you cannot have a value for that line. It's kind of a placeholder. Now, if you look at the 2 undefined, see where my 2 fingers are on the graph? There are 2 undefined. There's one at 0, there's one at pi. If I go halfway between those 2, you always find a 0. There's always an intercept. So halfway between the 2 dotted lines, in this case is actually pi over 2, is going to be an intercept. That's going to be a 0. Now if you look at your cotangent column, and you go down the cotangent column, it starts at radical 3, which is 1.7. It comes down to 1. It goes down to radical 3 over 3, which is probably like 0.8 or something. And then it goes down to 0. And then it starts going back up to 0.8 and so on if you go in the other direction. So what we would do here, actually it starts going back, it starts going down. Negative 0.8, negative 1, and negative 1.7. So it starts up at the top. At the halfway point is where you would get your 1 value. So it starts at the top and it works its way down. If you go down to -1, that would be the halfway point for these two, at -1. So it's going to be a curved graph like this. Now, how does that compare to our tangent curves from Friday? Is it the same? Or is it a little different? It's a little opposite, right? It's close. But the tangent graph started at the bottom and worked its way up. This graph starts at the top and works its way down. So that the cotangent is going to be up on the left side so that it can come downward and work its way across. That's a cotangent curve. It's also different in where the dotted lines are. Here the dotted lines are at 0 and at pi because it's a cotangent. That's where it's undefined. Tangent was at pi/2 and -pi/2 because that's where the tangent would be undefined. So there's some similarities in the sense that it's got 2 dotted lines. This is where the dotted lines are. And it's another curved graph. It's just the opposite. Now, we did have one on Friday that had this curve to it. It was your third graph, example 3. Now, why was example 3 the same direction? Because it was a negative tangent. Negative tangents are the same as a cotangent as far as the direction. Negative cotangents would be the same as a tangent, because it'll flip it around. The negative always flips it the other direction. That's what a negative does. All right, let's look at the next example. Example 5. We're going to do y equals 2 cotangents of x over 3. X over 3. Okay, so this is a cotangent graph. Where is cotangent undefined? 0 and pi. So I need to take this amount and set it equal to 0, and I need to set it equal to pi. I got to find out where my 2 dotted lines would be, and that's how I do it. Find out what would make it equal 0, where the dotted line is, and what would make it equal pi, where the other dotted line would be. Now, this first one's pretty easy to solve. You just multiply by 3, and what's 0 times 3? 0. So you're still going to have a dotted line at 0. So if I did draw my graph, I'm still going to make a dotted line on the y-axis, because 0 is still an asymptote. So that is going to be one of my dotted lines would be at 0. What do I get if I solve the second equation, though? I need to do what on both sides here? Multiply by 3 on both sides. So that cancels out. You get x equals 3 times pi, which is 3 pi. That's going to be where your other dotted line is. So you're going to go 1 pi, 2 pi, 3 pi, and make a dotted line. Now let's just test it. Let's see if that's really undefined or not. Let's take 3 pi and plug it in for my x number. So what would 3 pi divided by 3 equal? Pi, right? And the 3's cancel out. So what is the cotangent of pi on your chart? Cotangent of pi. Undefined. So yes, it is the right place to put my dotted line, because if I put in a 3 pi, that's going to make this become pi, and it's going to make it be undefined. So 3 pi is where I want to put my dotted line. Now, what do I know about the halfway point between these 2 dotted lines? Got to be an intercept. In this case, it would be at 3 pi over 2, or 1.5 pi. Has to be an intercept. Now, normally, halfway between these two would be, I'd go up 1 and I'd make a dot. But what's in front here? A 2. And if this came out as a 1 and then I doubled it, now it's going to actually come out as a 2. So the halfway point's actually going to be a 2 here because there's a 2 in front. And then down -1, -2 on the other side is going to be a -2. So you're going to draw your cotangent curve. So that would be the shape and the direction of your cotangent curve. Most important things that I will be looking for on your graphs. Did you get the dotted lines in the right place? That's what I want to see for sure. Did the dotted lines get put in the right place? And did you put the right direction on your graph? Tangents, cotangents, I mean, start at the top and work their way down. If this was a negative, it would have started at the bottom and worked its way up. So you got to get it the right direction. You got to get the right dotted line. That's what we're looking for. Let's go to example 6. Example 6 is going to tell us to graph y equals cosecant of x. So we've done sine, bow tie, cosine, which was a V shape. We've done tangent, which started at the bottom, worked its way up. We did cotangent, which started at the top, worked its way down. We need cosecant and secant, last two. Plus I have one last example after that, so there's 3 left. Cosecant curves. Now that would be on your chart as well. The very last column. Very last column. What is the cosecant, the reciprocal of? Sine, not cosine. Remember, you gotta have a cofunction. So you got a sine and a cosecant. You've got a cosine with a secant. So this is the reciprocal of the sine graph right here. So what we need to do for a cosecant graph is, number 1, we have to draw a sine graph. We have to do this because this is our guide. This is going to help us draw the cosecant graph. You can't really draw the cosecant graph without knowing where the sine graph is, because it's a reciprocal of it. So if I was to draw this graph down here, I would need to get the amplitude and the period. Because when we want a sine or a cosine, we need the A and the P. Amplitude would be the absolute value of 1, which is 1. Period would be 2 pi divided by 1, which is 2 pi. So there's a 1 in front of here, and there's a 1 in front of there. So if I was to draw that sine graph, I would go over to 2 pi, and the sine curve looks like what shape? The bow tie, right? So it means I start at the center, I end at the center, or at the intercepts, and the halfway point is also an intercept. A sine curve has 3 intercepts. It looks like a bow tie. This middle point is the knot to the bow tie. Between the first 2 is going to be a maximum. Between the second 2 is going to be a minimum. That's because it's a positive sine graph. It always goes up first and then down second. Now I'm going to make it a dotted line. The reason is because this is not the answer to my question. They're not asking me for the sine graph. They're asking me for the cosecant graph. So this dotted line is a guide. That's what I was trying to tell you here. This is gonna help me find out where to graph the cosecant at. Now on your chart, I need you to look at something. Are there places where the cosecant is undefined? Yes. Now when it's undefined, what was the sign at that same time? Okay, sine was 0, cosecant was undefined. Is that true for all 3 of them? Yes. So anytime the sign is 0, your cosecant is undefined. So where is the sign 0 on this graph? When it's 0 is all 3 of these points, isn't it? So you're going to put a dotted line here. You're going to put a dotted line here. And you're going to put a dotted line on the y-axis. Because those are all the places that the sign was 0. Wherever the sign was 0, your cosecant has to be undefined, because if you flip over the 0 can't go on the bottom. It's undefined. So these are your dotted lines. That's why I said you need the sine curve to guide you to where the dotted lines would go for your cosecant curve. Now the last part of that it guides you in is it tells you how to draw it. Now the cosecant curve is going to be a U shape, Wherever there's a maximum, you're going to get a U-shaped curve. Wherever there's a minimum, you're going to get an N-shaped curve. So notice how I did those in solid lines, because those are really the two answers. These are all the values for the cosecant of x. These are all of these values. And those are all the values on your cosecant. So any single one of these we could plug in, like this 2 right here at the top. At 30 degrees or at pi over 6 radians, your cosecant is 2. So let's test that. If I go over to 30 degrees, okay, this is 180. So 30 is going to be like right about there, really short, right? So if I go over 30 degrees, I should go up to 2. Okay, well here's 1. So if I go 30 degrees, I'm going to be on my graph about there. Is that about 2? Give or take a few, yeah, because my graph's a little, free-handed. So yeah, that's going to be about 2. That is a point. Those are the points on your cosecant curve. The top half are positives, that's these. The bottom half are negatives, that's these, down here at the bottom. So you can see the two different, that's the cosecant curves. So you had to use the sign as a guide. The sign guided you to where these two U's and N's had to be. Secant graph does the exact same thing, but what graph would be our guide for the secant? Cosine. Remember, cosine and secant are reciprocals. So to get the secant graph, example 7, to get y equals the secant of x, you need to first draw y equals the cosine of x. So again, you would need your amplitude and your period. Amplitude would be 1, and the period would be 2 pi. So to get your secant curve, first draw your cosine as a guide. Now what shape is the cosine? Cosine is the V shape, right? The V, it looks like a V. Now if the cosine was negative, it would be an N shape. But when a cosine is positive, like this one is, positive, you're going to make a V-shaped curve. So the period is over to 2 pi, and our amplitude is 1. That means we go up 1 and we go down 1. So I'm going to start at a maximum value. Remember, the cosine is a V, so it starts at the top and it ends at the top. Now, what do we know about pi in the middle? Cosine of pi. If you look at pi and look at the cosine, it's -1. That's the minimum value. So at pi, your cosine is the lowest it's going to get. And then halfway between these two would be your two intercepts. So here would be my guide. I'm going to put it as a dotted line because it's just a guide. It helps me draw my secant graph. Like, where would my dotted lines go? Because in secant, there are some undefined areas. Wherever the cosine was 0 was an undefined area. So where is cosine 0 here? At the intercepts. Good. Cosine is 0 at these two intercepts. That's where the cosine would be 0. Now you've got only 2 dotted lines. I need one more. You can add it to either side. So if I was to keep this dotted line going, it would come down to here, right? So this will be another intercept. This will be another dotted line right here. You can do it on the other side as well. So it's our V shape, but we added a little to it to get the last intercept. Now you can do an N shape here, and you can do the U shape right here. Those darker values are the secant values. I had to use my cosine as a guide to finding where the dotted lines went. So that was all 4 graphs. I've shown you all, actually, the sine, cosine, tangent, cotangent, secant, cosecant. I've shown you all 6. I'm going to do one more, and the one last one that I'm going to do is actually number 15 on your homework. So I will give you a one free one that you can just add onto your homework later. Okay, it's example 8. Okay, and it's going to be the graph y equals secant pi x minus 1. Secant of pi x minus 1. Okay, so what do we know about that graph? Okay, A, I'm going to need cosine, right? What else do I know about that graph? It's what? I heard the shift word, right? It's a shift? Is it right, left, up, down? What do you think?
Down.
Up. Sabrina says down, Justin says up. Nobody says right or left.
Left.
Right. So we got everything covered now. Could be one or the other. I got you. All right. This is exactly what Sabrina said. It's a shift down. Okay, now normally, if I had put these right there, now it's a shift to the right because I combined the -1 with the x. But when there's no parentheses, the -1 is standing all by itself. The secant of pi x is what you have, and then you subtract 1. So this could actually be written as -1 plus secant of pi x. Now would it look like a shift down? Now it would look more down than it would the other way. But this -1 could go in the front or in the back. It doesn't matter. So I'm gonna bring this over here though as y equals -1 plus cosine of pi x. Because remember, I need my guide here. I need to know where to put the dotted lines. I need to know where to put the U and the V shape, or the U and the N shape. So what is my amplitude and my period of this bottom graph? Amplitude would be the absolute value of 1, so that is 1. Period is 2 pi divided by what? By pi. Pi is in front of the x. And what is 2 pi divided by pi? Just 2, because the pi's cancel. So when I draw my graph, I'm going to have 1 radian, 2 radians, not 2 pi. It's 2 radians. The pi's canceled out. So I'm going to use that. Now, what shape is this cosine graph? Well, the shape of a cosine is a V shape, right? The V shape. So I need to go up 1 and down 1, and I need to start. Hold on. Don't do that. I want to show you something really quick. In red, you don't have to write this down, but in red, I'm going to show you what it would have been if this 1 wasn't there. If there was no -1, we would have started at 1 here. We would have gone to an intercept. We would have gone to a minimum. We would have gone to another intercept. We would have gone to a maximum. And this would have been our curve if the 1 wasn't there. What is the 1 telling us to do? Go down 1 unit. So all of these points need to come down 1 unit. So that means that I'm in black writing, I'm going to put the correct one, which you would come down to the origin. This would be down here at -1. This one would actually be down at -2. This one would be back at -1. This one would be back at the intercept line. Not an intercept, but it's on the 0 line. And that dotted line is my guide. That's going to help me draw the secant graph. Where would the dotted lines go? That's the key question. Is it going to go on these two, the two maximums here on the dotted line? Is it going to go on these two middle ones on the dotted line? What do you think? It has to go at an intercept. An intercept is halfway between a minimum and a maximum, so it has to be on these. So you're going to do a dotted line here and a dotted line here. Those would be your vertical lines. You can see the N shape is going to go right below the minimum value on your dotted line. Now we could finish our curve here, go over another to 2.5, come down to another intercept. So we could draw one more dotted line, and that way we could do a U-shaped curve up here. So that, the filled in curves there would be my secant values. The dotted line here would be my cosine values. So I needed the cosine to tell me where the dotted lines were and to tell me where the U shape and the N shape would go. So that would be the cosecant of pi x minus 1. It's number 15 on page 187.